React native modules was probably one of the most difficult things to work with, mostly because the documentation is very scarce and very few people have actually worked on it and had a good experience. So today I'm going to do my best to explain native modules to the best of my ability and to my current level of understanding. So I found this very interesting article, um, and this article is written by the company Tea Break from Andre, and it talks about how native modules works. So it actually React Native Modules uses Objective-C, but they actually explain the process of um, using Swift and the Objective-C bridging header. So you have the React app that also is calling the React Native module, and this module is talking to the Objective-C class, and then your actual implementation is done in the Swift class with the Objective-C header. So I'm going to go through this example with you. So first thing is you can just use React Native init to init a counter app. Nothing too special there. When you open up the Xcode project, what you want to do is you want to create a Swift file, and then what happens is when you create a Swift file, it's going to prompt you for the Objective-C bridging header, and this is when you create the bridging header, and then you make sure that the build settings is set correctly, and then you'll see something like this. So I've actually done this work, so I'll show you what it looks like. So in the counter app, what you'll see is you'll see the bridging header, and you can see that the React Native bridge module is imported in, and you'll see that the counter we have actually exported some of the methods and the modules that we'll be doing, but you'll see that soon enough. So what happens is you declare your Swift class like so, right? And you see this Objective-C header, and this header exposes the Swift class to Objective-C, which in turn allows React Native to have access to this class. How to expose the Swift class to JS. You see here for the counter Swift file, we also have a counter.m file, which here, this macro RCT extern module allows us to export this counter class as an NS object to JS. So here, this is exactly what I was talking about, the counter, which is exported, and we have these methods that we want React Native to be able to access. And these methods are defined here in our Swift file. Okay. So it also talks about you can also rename your method names, but you can read that on your own. So what happened next is you wanted to, in your React Native side, you want to be able to access it by importing the native modules from React Native. So let's look at React Native side. So here I just made a simple demonstration where I just imported native modules. And the way you call native modules, you can just call native modules the class that was exported it and the function that was declared in Swift. And that's how you would be able to access the data, make a method call in Swift. So, so let's see how we are going to pass data around. So the first thing that you're going to notice is you're going to be using this special function. It's called constant exports. So it allows these constants, this constant, initial count, to be exported to React Native. So in our code, we see constants to export. So it actually returns a bunch of stuff. And then in React Native, you see that we don't have constants to export. That's because that's a specially named function. You can see here that was the function, that was the things that I wanted to return. And you can just get it out in the JS console. And then you also wanted to set up a main queue setup because you needed to tell React Native whether this module is running on the main thread or not. And then that's what this warning is about, which is why in Objective-C land, you wanted to set this. Now, what you want to do is you want to learn how to expose a Swift method. So what's going on here is you have a private method, a private variable called count, and then you have this function which increments count. And now we're going to export this function. And the way you export it is through RCT extern method increment. And in native modules, when you call this function, it's going to increment this variable count on the native side. So let's see how that works. So here on the native side, we decided that we wanted to increment. Don't worry about the send event first. And then we export this increment method. We call it in React Native. And then in Xcode, in the native side, we get the console log. So that's how React Native can call it. And you can also rename your method. One interesting thing is you can expose a Swift method with a callback. So what does that exactly mean? So what happens is here is we have this function getCount, which takes a callback, and then we're going to execute the callback with the array of arguments that gets passed in. This callback gets exposed with getCount as the method name, and the argument callback is a type RCT response sender block. And in your JS side, you're going to pass in this callback as a function where the value that you receive is going to be console logged. And now you're going to be able to get this count in JS land. So let's look at this in code. So what's going on is we have a callback. So we have a function that's defined getCount with no method name, callback. And what's going on is we're going to execute this function when getCount gets called. And getCount is going to get called here on the React Native side. So React Native is going to call getCount with the array of arguments. So callback always takes in an array of arguments. So that's what this array, that's what this first and ... others is. So when native calls getCount, it's going to execute the React Native function, which just console logs the first and the others. And native is providing the arguments for React Native to call. So it's a way for native to access some React Native functions. And then this part is multiple arguments. And what we can also do is you can have a promise. So a promise, so you can define how you like it to be resolved, how you would like the promise to be rejected. Right? So resolve only has one argument, which is the data. Reject has three arguments, which is the error code, error message, NS error object. So you can see here in the Swift file, we have our decrement function, which resolves, which takes in two arguments, which is the resolver and the rejector. And if the count equals to 0, then we can't decrement any further, then we call reject. Otherwise, we decrement the count and we'll resolve it. And similarly, we're going to expose this method, decrement, and you notice that this is the method name decrement. The first argument resolve, the name of the second argument, and the type of the second argument. And then on the React Native side, it's going to call decrement, and because decrement returns a promise, then we can resolve this promise with .then. If it fails, we can do .catch. And that's exactly what we did. So here I wrote this function, decrement. Here I'm using async, but the idea is similar, where we want to call this native function, which returns a promise, and if it's successfully resolved, we console log it, else we catch the error. And on the native side, the decrement is also very easy. It's decrement, we take in two arguments, the resolver and the rejector, and then we say in what cases do we reject and in what cases do we resolve. And JavaScript will handle the implementation for resolver and rejector. So that is a promise. This part is async await. Something else you could do is an event emitter. What an event emitter does is it allows an event to be emitted from native side to the React Native side. So you need to import the RCT event emitter, and then you need the interface to also takes emitter as one of the arguments, I think. I'm not too sure. You can correct me on that. So we need to update the bridging header. Oh, okay. So this is a subclass external module. Okay. It looks like it's a subclass. Looks like our event, Swift event, is a subclass of RCT event emitter. Implement supported events. Call the send event. You can specify which specific event you want to send, and then you need to do the override for constants to export and require main queue setup. So what we're going to do here is now our counter, our class, is a subclass of RCT event emitter. And what we want to do is when we increment the counter, we're going to send this event to React Native side. The parameters is the on increment, and the body is just our count variable. Now you notice that here because we're subclassing, so now we're using this override keyword for supported events. You see that constant exports get also changed to override. Require main queue setup is also changed to override because now we're subclassing the RCT event emitter. And this supported events just tells us what event we are emitting. Okay, so now the JavaScript side, we're going to subscribe to the event that's emitted. So we have a event emitter from React Native. and we're going to grab the counter events from event emitter native modules counter, which we specified earlier. And we're going to subscribe to the onIncrement event that is defined here in supported events. And when it increments, we're going to console log our result or do everything that we want to do. So this way, we can listen to changes on the native side and adjust accordingly on the React native side. And that's sort of a high-level overview of how to work with native modules and pass data around. It's not something that's very easy and intuitive. And when you actually work with it, you'll find a lot of nuances that you need to understand. Hopefully the re-architecture is going to make this a lot simpler. And I'm hoping that there's more people that are going to be working on this and providing more resources for React Native developers that are working on integrating React Native into existing iOS or Android apps. Thanks.